Dalton, Thomson, Rutherford, and Bohr, Schrodinger and Heisenberg, and many, many more used their brains to venture in the realm of inner space and found the world of the atom was a weird and wondrous place. Dalton did experiments and said, I think it's clear atoms are tiny indestructible spheres. Thomson worked with cathode rays, said I disagree. A plum pudding model makes much more sense to me. A new chapter in atomic theory started to unfold.
So you know what comes on if you teach science, this atomic theory or model building, and that's what this is all about with this very high-tech device here. This is called a Dazer. Dazers are made with a little metal dimple here, okay, right there. And then they have some kind of an image on them. I've seen them with yin and yang. I've seen them with spirals. I've seen them with eyeballs, all kinds of colored ones. And I said to myself, I haven't seen one with an atom. So I found out the company that made them. I had an atom that I designed, and I sent them the artwork, and they said, we can't do that. So there was a compromise, and this is the image we ended up on here. I did have them, however, put some holographic a grading material on that has 14,000 lines per inch. And because of that, when you look at it at different angles, you'll see different colors, light given off, which I'll show you in a moment. So if we look at this model of the atom, you might ask your students, whose model is this? And they would say, sure, right away, just like mine, they would say, that's the Bohr model, Mr. Merrick, or maybe not right away. The Bohr model. And most kids, that's what they think of this whole concept. It's kind of boring. Now, that's good, but the Bohr model is not the final model. And that final model is the electron cloud model, or that's one of them. Now, as you can see with this model that we have right here, here's the nucleus. And I had it anatomically made correctly. There's some quarks within the particles within the nucleus. There's 3 quarks. You could see that with some. We have protons, we have neutrons, and you can see the 3 little dots. Because I work with Fermilab over the years, I wanted to make sure the quarks were in there too. And then we have the electrons in some kind of orbitals out there. So this is the Bohr model, and if we spin it, we can go to the electron cloud model. No longer are the electrons easy to see. They're kind of in a cloud around the nucleus. And the other neat thing, that if you look at this at different angles, you'll see different colored lights given off. It's a little hard for the camera to pick that up. It's easier for your eyeballs. It's a better camera than the ones we're using. We have top-end cameras, but your eyeballs are still better than the best digital cameras right now. So if you look at this at different angles, let me see if this works any better, you'll see different wavelengths of light given off, kind of like the transition with the electrons between different energy levels, okay? So I know what you're saying. That's great, Merrick. That's a great Bohr model, but it's not the best I've ever seen. And that's even better, because any model is going to have flaws. It's not going to be 100% correct. If it were 100% correct, it would be the real thing, and this isn't. So what you could do is you could set up cooperative learning groups, put 4 kids in a group, give each group one of these, have them try it, they'll think that's cool, and then the uncool part for them will be they have to write something up. You could have them write up, why are these models wrong? What's wrong with this model? What are the imperfections within the model, both the Bohr model and the way this electron cloud model is pictured? There's all kinds of flaws in there. So this involves writing across the curriculum, models, analogies, the whole 9 yards, and they're forced to not just look at this spin and say, that's cool. They're forced to actually think about what's going on and relate this to the Bohr model, the electron cloud model. And one final note, the songs you heard at the beginning was one of the songs from one of Mike Offit's albums, and I can't recommend these highly enough. Chemistry to Songs. You may think, nah, the kids aren't going to like that. They love it. It gets stuck in their brain, and it hurts. What could be better than that?